Goto there and back again. So I'd like to tell you a story. I'm going to start by introducing you to this man. This is Edgar Dijkstra. He was a Dutch computer scientist. This picture was taken in San Francisco in 1972 when he was giving a Turing Award talk for the ACM. When the ACM gives you the Turing Award, you get to give a speech. And he gave a very good speech called The Humble Programmer. And you can find the speech on YouTube and other places. It's worth taking a look at or listen to. He had a lot of very strong opinions which were extremely controversial at the time, which turn out to have been correct, which is a pretty neat thing. He wasn't correct about everything, though. There was one thing that he didn't get right, and we'll get to that later. So he was given the Turing Award because of the body of work that he had done in operating systems, in garbage collection, in programming languages. He was on the Algol 60 committee, but he is best remembered for having written a letter. He wrote a letter to the editor of the communications of the ACM, and it's a really important letter. I'd like to share it with you. It was published with the title, Goto Statement Considered Harmful. So Dijkstra writes, "For a number of years, I've been familiar with the observation that the quality of programmers is a decreasing function of the density of Goto statements in the programs they produce." Now, this is actually a very arrogant statement because he's observing a lack of quality in the programmers, not a lack of quality in the programs that they write. So he's saying this in maybe the most rude way possible. But he goes on. "More recently, I discovered why the use of the Goto program has such disastrous effects." He's using the word disastrous here, which is an overstatement, and he's making the problem sound much worse than he is. It's alarming. "And I became convinced that the Goto statement should be abolished from all higher-level programming languages." So that sentence started an argument, a heated argument, an angry argument that went on for 20 years. He was proposing that the Goto statement, which was in all of the popular programming languages at that time, should be completely eliminated. And it was a very divisive debate. So let's look at how it was organized. So Dijkstra was the leader of the radicals. And the radicals were saying that the Goto statement is a disaster and it must be eliminated. On the other hand, you had the reactionaries. The reactionaries were people who were writing Goto and were happy writing Goto and did not want to change. And they had a number of arguments against Dijkstra. The first one was for performance. They claimed that programs that used the Goto statement were going to be much faster than programs that didn't use the Goto statement. They made that claim without any evidence, but it seemed like it was true. And so it was a very forceful argument. They argued in favor of tradition, that we had always had Goto, we should always have Goto. My grandfather used Goto. You can't take the Goto away from me. It's part of our national identity. They talked about freedom. You can't take it away from me. I have a right to use the Goto. That's who I am. I'm a Goto guy. I need to have my Goto. You can't take it away from me. There was the pride argument. So obviously, there are some people who will write low-quality code using the Goto. It is an insult to suggest that I am one of those people. I'm someone who can use Goto really, really well. And then there is the majority argument, that there are only a few radicals and all the rest of us use Goto, therefore all of the rest of us must be right. There is also a meta-argument, our list is longer than your list, so therefore we must be right. Then there are also the moderates. The moderates tried to see both sides. They recognized that, yes, in fact, there is a problem with the Goto, but they were not prepared to get rid of it entirely. So they tried to find a middle ground. We should avoid the go-to where possible, but sometimes it's useful, and so we should have it available for those cases. It turns out that the radicals were right, that the go-to, in fact, was problematic, and that we didn't need it, and that we could write better programs more easily not having the go-to. But they never won the argument. So let's look at the timing on this. So Dijkstra publishes his letter in 1968. Now, it turns out this was not an original idea. When he was working on the Algol 60 report, someone had suggested to him in 1959, maybe we shouldn't put a go-to into Algol. And he thought that was a crazy idea. But 9 years later, he started to understand the wisdom of it. Dennis Ritchie, 5 years later, produces the C language. Ritchie is a moderate, so while he doesn't use GoTo a lot or badly, he does include GoTo in the C language. A decade later, C++ comes out. It has GoTo in it. Another decade later, Java comes out. Java does not have a GoTo statement in it, and it is wildly successful. Java is one of the most successful introductions of a new language in history. But GoTo is a reserved word in Java because they weren't sure they were going to be able to get away with it. And so they gave themselves license to stick GoTo back into the language if it turned out people got really upset at them. So this was an argument that went on for decades, and it was a loud, noisy, emotional argument, and went on and on and on, and then one day it sort of stopped. And we looked around and, are they gone? Can we get rid of it now? And it turned out, yeah, we could get rid of it. And all of the predictions that the reactionaries had made about how we weren't going to be able to do good work and our profession was going to be degraded, none of that was true. So this illustrates something that's really important about how we make progress. Progress does not wait for the next new idea. It waits for consensus on an old idea. We like to think that we're just waiting for someone to have an idea and then we'll all recognize and go, yes, that's great, and we all adopt it and we all move forward, and that's how progress happens. That progress is waiting for the next idea, and that's not how it works. The ideas happen all the time, and we're resistant to them, and eventually the idea is allowed to go forward, but it takes a long time. So the reason the GoTo thing took 20 years to resolve was that with all of the arguing, minds were not changed. What happened was we had to wait for a generation of programmers to retire or die before we could make progress on the new idea. And that happens all the time. So I think the biggest difficulty we have in programming is the problem with bugs. That programs need to be perfect in order to operate correctly, and we do not know how to make perfect programs. And so as a consequence, bugs occur all the time. And much of what we're trying to do as a profession is to try to figure out how to make better programs with fewer bugs. So one of the first computers to come online was the EDSAC computer in England that was, I think, operational in 1946. And it was designed and built by a mathematician named Maurice Wilkes. And he wrote a really interesting reflection on his experience with it. As soon as we started programming, we found out to our surprise that it wasn't as easy to get programs right as we had thought. Debugging had to be discovered. I can remember the exact instant when I realized that a large part of my life from then on was going to be spent finding mistakes in my own programs. And, that's our life, that we're still doing that. So, in the late 60s, something occurred called the software crisis. It was observed that software projects were very often over budget, that they were over time, that they were very late, that the software produced was unreliable, that the requirements were not fully met, that the systems that were developed were not maintainable, and sometimes the projects would totally fail. Does any of this sound familiar? So this was a real concern, that as the computers got bigger, we became more ambitious about what we could do in software, and as the software got more complex, it got more difficult to make well, and the software crisis occurred. And the software crisis is still going on. We have not figured out a way to get rid of it. We just don't talk about it anymore because it's just become, it's like air, it's always around us. So Dijkstra talked about this in his talk, and he was concerned about bugs, and he, as a mathematician, had an idea for how to solve it. And his idea was proofs of correctness. So similar to the way that you might have an assertion in mathematics and you'll compose a proof which will prove the assertion, he thought they could do a similar thing with programs. And so he spent a lot of time thinking about how to do that, how to construct proofs of programs. And he and many other people who were working in this area were very confident that that would allow us to finally make programs that were free of bugs. And in his talk, he says that tests can only prove the existence of bugs, not their absence. So that test-driven development, he said back in '72, is not going to work, and he was right. Testing is definitely something we should do, but it is not sufficient for getting high-quality programs. Unfortunately, this didn't work. This was the one thing in his speech that didn't hold up today in the future, that it turned out that the proofs were much more complicated than the programs. And the bigger the program got, the bigger the proofs got, much, much bigger, so much so that the proofs were impossible to finish. Donald Knuth made a joke out of this. He published a program in 1977 which contained the comment, "Beware of bugs in the above code. I have only proved it correct, not tried it." This very clearly showed the problem with the proofs, that the proofs really didn't seem to have any effect on whether or not the program actually worked correctly. So that was disappointing. So we were left without any way of trying to determine if we could make bug-free programs. But then there was an observation about types. So in the early machine language, you'd have a word, and a word could contain a number of bits, and those bits could represent an integer or a real number or one or more characters or an instruction or an address or maybe other things. And it was the programmer's responsibility to remember what the type was of every word in memory to make sure that the correct instructions were used with it. When we started getting high-level languages, the languages would allow for declarations. So in Fortran, for example, you could say that something was an integer or something was real or a character, and then it would know what operations it would allow on that variable. So there was the idea that maybe systems could be built out of types, and types could do the thing that proofs of correctness failed to do. One of the major proponents of this idea was Robin Milner, who developed a brilliant programming language called ML. And in '78, he said, well-typed programs cannot go wrong, which is obviously not true. But he had a lot of excitement about what he thought he could prove with types. And in fact, there's a very large community that's doing research in types, and some of that research is really interesting, but I don't think they've actually proven their case yet. So let's look at the argument here. So the radicals on the subject of static type checking say that it's not worth the freight, that there's a big expense in having to deal with type systems, that the type systems, because they interfere with normal development, actually cause mistakes of their own. And possibly they cause as many mistakes as they may be preventing. And so when you consider that with the additional effort that they cause, maybe they're not worth it. The reactionaries are very resentful about that. They say, no, you're completely wrong. It only requires a little bit of extra effort to do the types. It's work that you would probably be doing anyway, and it's helping you. So stop complaining, types are good. Then the moderates are trying to be in between, saying, if the types are helping you, then use the types, and if they're not, then you should be free to do what you want. And who's right in this case, we don't know yet. The argument is still going on, and it may be another generation or two before it gets worked out. So Milner's promise hasn't been kept yet. I'm hoping someday it will. I'm very happy to see that we're still doing research in type theory. And maybe someday something will be discovered that actually is worth the freight, but we haven't seen that yet. Now, while the Goto thing was going on, there was a joke that was in some of the trade press that as long as we're getting rid of the Goto statement, we should also get rid of the come from statement. And people proposed adding come from statements to languages just so that we could then go and remove it from the languages. But it turns out in many of our modern languages, we have a come from statement, we just spell it differently. The way we spell it is extends. It's the thing that allows one class to inherit from another class, but what it actually does, it says stuff from this class comes from that class, and that creates a very tight coupling between the two classes. And we know that tight coupling is a bad thing, that it makes brittle systems. We generally want to have loose coupling of very coherent modules. And classes don't do that. Classes have this very tight coupling, which creates problems and generally leads to refactoring and other nuisances. So JavaScript, to its credit, at least until very recently, was class-free, which I think actually put it forward and compared to other languages. Unfortunately, in ES6, classes were added, so now JavaScript in some ways is as bad as all the other languages that came before it. Fortunately, there was a really good feature added to ES6, and that is proper tail calls. So if the last thing a function does is return the result of calling another function, the compiler is required to do something different than it used to do. So it used to generate a call return sequence. So it would stash the address of the next instruction and then go to a function, and that function, when it's done, will go back to the original one, and then the program resumes. So in ES6, that behavior changes. So now it's going to generate a jump, a Goto. So we're adding Goto back into the language, but in a really nice constrained way. So it's a parameterized Goto. This is an idea that was discovered in the Scheme language. It's very compatible with functional programming. It gives us an alternative to doing loops and other sorts of control flows, but without the problems that came with the Goto. So it's a really nice thing. I'm very, very happy that we're getting this in ES6. Now, while we're talking about Gotos, there was a Goto that was in the news a few years ago that Apple had an implementation of SSL, and like most implementations of SSL, it had a really nasty bug in it. And this bug was called the Goto fail bug. So let me show you the bug. This is the actual code, or snippets of the code that caused the failure, and it was a huge security failure. And looking at this code, there are a number of things that are wrong with it. For example, there is an assignment in the condition part of an if statement, which is really, really bad practice. Nobody should ever do that. And then the if statement itself does not have curly braces around the consequence, which is another very, very bad practice. And then he's got a Goto statement. Goto is a really bad idea. And the Goto statement label is wrong. It says fail, but what it actually is exit. It's getting out. But there are paths of getting to this label which are not necessarily failure. Then the actual bug itself is that there was maybe a copy and paste error so that the Goto statement was in there twice. But because of the rules of C grammar, the second Goto is executed unconditionally. And so that meant that there was a way to get to the return with error not containing an error code, but a success code. And that told the caller that all of the security checks passed, when in fact all the security checks hadn't passed. And it was a big failure. So it's kind of puzzling, why is Apple still writing code this bad? And you wonder, who could do something like this? How could a professional programmer write anything this bad? And I start to think maybe Dijkstra was right. You know, when he talked about the quality of the programmers, I think what he wrote was really rude and arrogant, but I think maybe he was right. So one of the reason why this stuff takes so long, the reason it takes a generation or more to accept a good idea, is because these good ideas represent a paradigm shift. A paradigm shift is something which needs to be experienced. We can talk about a paradigm shift, but if you haven't experienced it, you don't understand the conversation, although you think you understand the conversation, and so it's really easy to come up with incorrect opinions. And often you can hear that when an objection to something is stated in this form. Like, I have never done Goto-less programming, so I don't see why we shouldn't use Gotos. Or I've never done object-oriented programming, so I don't understand why we need to do object-oriented programming. That you come from a place of comfort and experience, and you're presented with a new thing, and you've been successful in your career, so this new thing must not be necessary because you've been doing okay without it. But then you don't get to move on. And so there are lots of things in this category. I've never done tail calls. I don't see why we need tail calls, but in fact you do need tail calls. Tail calls are a really important new feature in JavaScript. And you know, I don't see why we need to do functional programming, because I've never done functional programming and I'm a good programmer. So these are all examples of a paradigm shift. The thing that makes paradigm shifts so really difficult is it's really difficult to tell the difference between a paradigm shift and a really bad idea. Until you've gone through the thing, it's hard to tell. You know, and we had one recently. Anyone remember XML? Anybody? Yeah, so that was one of those, right? The people who got on to XML really early thought, this is a paradigm shift and it's going to change everything and this is great. And it turned out it wasn't great. So it's really hard to tell. It takes experience and time ultimately to figure it out. So one shift that we're starting to get to now is in functional programming. Functional programming is something that has a very long history, and it's just now starting to become a dominant idea, but it took a long time. So let's look at the timeline for functional programming. So it starts in 1958 at MIT with John McCarthy and Lisp. Lisp was a programming language that was intended to be used for artificial intelligence. And initially it was, McCarthy's plan was it was going to be a language that was going to be similar in many respects to ALGOL. But he stumbled onto lambdas and put lambdas into the language, and that kind of completely changed everything. And so in 73, Milner is working on ML. In 75, the scheme language is discovered, also at MIT. And in Scheme, they make some really fundamental discoveries, which it starts off as a Lisp dialect, but it turns into something really important. First off, they come up with an idea of nested functions with closure, so that an inner function statically binds the variables of the outer function. I think that is the best idea in the history of programming, and was discovered in Scheme. And as usually happens with the best ideas that ever happened, nobody pays any attention for quite a long time. A decade later, that idea gets incorporated into Common Lisp. Haskell, another AI language, or functional language, is developed in Scotland. And then in 1999, the third edition of ECMAScript comes out, which has inner functions, or function expressions, which work exactly like the functions in Scheme. And this was really important. So JavaScript is the language that brings that idea of functional programming to the mainstream. The JavaScript is quickly followed by Python and Ruby, and then C#, and I guess just last year, Java finally caught up to it. So it's a really important idea that's in all of the languages now. So we still need to figure out how to make our programs better. And it's a difficult thing because proofs didn't work. Getting rid of gotos was an improvement, but it didn't work. Types don't work, so how testing doesn't work. Testing's hugely important. We absolutely have to test. But even if you wrote all the tests and everything passes, which doesn't always happen, but even when it does, you still don't have proof that your programs are correct. So what can we do, to make our programs better? And I recommend doing code reading. So we've long had the idea that when a project is finished or getting near a milestone, we'll do a code review, where we'll have someone sit down and read all of the code that we're about to commit and look for problems. And it's a really worthwhile exercise, because you can find, by careful reading, things that are very difficult to find by testing. Unfortunately, this usually happens just at the end of a project, and usually the project is running late, and so they skip it, or they hurry it, or if they find things that are problematic in the code, they decide not to change it because there's no time. So that doesn't work. So what I recommend instead is taking a practice that is used in the making of motion pictures. So when you're shooting a movie, the principals who are making the movie every day will watch the film that they shot the day before. They'll review it, looking to see, did everything work? How's the thing going? Are there any changes we need to make? Any things that we can improve? It's a really important practice, and they call it dailies. Every day they look at yesterday's film. And I think we should do that in programming. So every day the team sits down, everybody on the team, and everybody reads together the code that was written the day before. And there are lots of benefits that can happen from this. One is that we can get some mentoring happening. So the experienced guys can be showing examples of good code to the younger guys, and can be instructing them on how to improve their craft, how to be better programmers. We can make sure that everybody is working in the same direction. We can see that all of the interfaces are going to fit together well, that we're not going to get surprised at some later integration phase, because everybody is looking at everything every day. That the amount of new code that gets written every day isn't all that big, so it shouldn't take all that long for us to read it, but it's a really useful exercise. And by having everybody on the team understanding what we're doing, then we get more redundancy and integration will work much better. One important caveat, though, is this does not work with a dysfunctional team. So there are rules about this that nobody is going to get punished as a result of what happens in a code reading, that we're not doing it to hurt anybody, that everybody understands that there's a common objective of trying to make the quality of the code that the team is producing as good as possible. And as long as everybody on the team understands that that's the objective, you can get really good results from it. The other thing to watch out for is that managers cannot use that process to try to do evaluations. That if they're keeping score, whose code is getting the most suggestions and counting that against the programmer, that kind of stuff is really toxic, and it will cause the team to destroy itself. So everybody has to be understanding what the purpose of this activity is. So that's the end of my story, and I'd just like to leave you now with one piece of advice. I'm really serious about this. Please, everybody, don't make bugs. Thank you. So we have a little time for questions if anybody has a question.
Поднимайте руки, хотите задать вопросы.
Hello, thank you very much. I have a question. Did you have a chance to actually witness usage of this technique in real project? And how long do these meetings take?
I'm sorry, how long does a code reading take?
Yeah, daily.
It's going to depend on the size of the team and the difficulty of the work. If the work is very difficult, then there's not going to be much new code each day. If it's a trivial project, there'll be possibly a lot of code every day. So depending on the project, it might take a half hour or hour. And that might sound like a big investment every day, except I think the rewards that you get from it more than compensate for that.
Thank you for your talk. You said that functional programming is a new paradigm shift, and do you see that it will take over the objective programming and just eliminate it, objective-oriented?
It's a really good question. I think it's going to displace classical objects, but I think the concept of objects themselves is a really strong one and works with functions really, really well. I mean, that's basically what we're seeing in JavaScript. So the term object-oriented programming was invented by Alan Kay, who created a language called Smalltalk. And he thought of it in terms of communication, that you have all of these objects which can send messages to each other. And we build systems by having these objects and their patterns of communication. And he was disappointed that the thing that the industry picked up on was not the communication, but the classes. It was the communication that was the important thing. And I think as we embrace functional programming, we'll get back to the original insight.
Hi. What I realized is that when you look back to computer science history, like all this language which has existed, there are some patterns which are coming back all the time. Like it's like a trend, and then suddenly everyone jumps on that. What do you believe is, like, for a young computer scientist or programmer, which languages should we definitely look into, like, from the history?
From history, Scheme. I think everybody who's a professional programmer should at least be acquainted with Scheme. APL had some really interesting ideas in it that we kind of got lost. And we're in a renaissance of languages now, so there are lots of things to consider. Erlang, I think, has some brilliant ideas in it. I think the strongest original idea in Erlang was the Suicide Pact, where you can have multiple processes and they all agree that if any of them die, they all die. And that is such a brilliant way of thinking about how to make reliable systems. It seems counterintuitive that having things that with cascading failure is going to lead to reliability, but it works. And it surprises me that an idea that is so brilliant has not been copied in lots of other languages. So my advice to young programmers, all programmers, is learn as many languages as you can, because a good language should teach you. It'll change the way you think. And you can take those new thinking skills and apply them to the old languages and others. And it seems that the more languages you learn, the more quickly you can learn additional ones. So it's a really good use of your time. I'm discouraged that there are some universities who appear to be producing graduates who only know Java and nothing else, which I think is tragic. We should all be familiar with lots of languages.
Thank you.
Thank you for your talk. The first maybe question, so people do mistake, and why we want program never have a bug? Because there is another opinion, maybe we have to let program have a bug, but we somehow should make it not so harmful for us. Maybe using, like in Erlang, the dying processes and stuff like this. So because I think it's impossible, so program always will have a bugs, and just a question of amount of the bugs. And another question about languages, and I think you have concept of life cycle of language. It's designed by a group of people, or it should be one author, like Fred Brooks said. What is your opinion about how languages burn and dying? Thank you.
Yeah, so I would really like to make programs without bugs. I don't know how to do it. I don't think anyone knows how to do it, so we need to be pragmatic. But at the same time, we should still be exploring techniques which help us to at least reduce our error rate. And so I think we're in agreement there. In terms of how to design a programming language, there has only been one good programming language that was designed by a committee, and that was Algol 60. All of the other designed by committees, I think, have been pretty awful. And all of the other good languages were designed by one designer. And I think that's the way to do it. So I encourage everybody to be a brilliant designer and make languages. And then somehow the community needs to figure out which of those we're going to adopt. But yeah, I mean, you look at C, you look at Pascal, you look at Java, you look at Ada. There are so many languages. Python is maybe one of the best examples, and C#, all came from one principal designer.
Hi, thanks for your talk. You just say some time ago, just now, that young programmers must learn more languages as we can. I have a question. Should we learn old languages like Smalltalk, Scheme? Because I'm I think you get me.
Yeah, I strongly recommend you learn Scheme. Highly recommend that you learn Smalltalk. Smalltalk is maybe the best designed programming language in history. And unfortunately, it lost to C++, which is not one of the best designed languages in history. And it's unfortunate, but there is much that we can still learn from Smalltalk.
Thank you. I have one more question. How do you think should we learn the Lisp?
I'm sorry?
Should we learn the language Lisp?
Should you learn Lisp? I would recommend learning Scheme instead. Scheme is a simpler, cleaner language, and it's brilliant. So I would start with a Scheme.
Okay, thanks a lot.
Thank you.
Thank you. Quick question. Can you benefit from dailies by reviewing your own code if you work alone?
So in the case where you're a solo project?
Yeah.
Yeah,
exactly.
absolutely. Yeah. I spend quite a lot of time just reviewing my code, looking at it. Sometimes I do historical reviews of my own code too. You know, I'll come back to a project after a few years and look at it. And sometimes I'm surprised, like, wow, did I write that? I had no idea I was that smart. That's really code. I don't remember doing that. And sometimes I go, who was the idiot who wrote that code? I can't believe that I did that. And I have both experiences, and I learn from both experiences. So it's definitely worthwhile to review your own code.
Thank you.
Hi, Douglas. Thanks for your talk.
Yeah.
It was really interesting. Just have one question, maybe not about the bugs, but do you have any real-world examples of using Scheme or Lisp currently in a real new world right now?
Yeah, the Clojure language, which is, you could consider Clojure to be a dialect of Scheme that runs in the JVM. And there is stuff happening in production in Clojure. I forgot to mention that language, but that's also a very good one to consider.
Hello, Douglas, I'm here. Thanks for your talks yesterday and today, very interesting and deep. And my question is a bit philosophical, or I don't know. So, Chris Kaspersky is one of famous hackers, maybe you know, maybe not. So during some interviews he said that in the Arabian world there are a lot of great ideas in algorithms and so on. Can you agree with that, the first question? And the second is, do you have some examples?
Examples of what? I'm sorry.
Examples, maybe there are maybe Arabian people invented some programming paradigm, maybe some programming language, ideas, algorithms, or so on.
I'm still not sure what you're asking me. I'm sorry.
Okay, maybe I'll ask it after the speech.
I want to answer your question. I just don't understand the question.
Okay. Chris Kaspersky, one of famous hackers, and during some interviews he said that in Arabian world there are people developed great algorithms and some ideas. Do you agree with that? Do you know something about that?
In which world?
Arabian.
In the Arabian world, historically that's true. You know, you can go back to the 12th century and they were doing brilliant stuff there. I don't know what's happening now. I'm not familiar with it. I imagine that there's excellent work going on, but I'm not aware of it.
Yeah, that's a nice point, because if there was a lot of stuff in the past, maybe nowadays it's something interesting is happening right now, but we don't know.
Well, we see that there's that big internet center in Dubai, and so I imagine there must be wonderful stuff happening there, but I just don't know about it.
Okay, thanks.
Hello, Douglas. I join others in thanking you for the great talk.
Oh, thank you.
You said that the extending classes that extend other classes create tight coupling. And so I wanted to ask, do you consider inheritance an anti-pattern? And if you do, do you think it will die off at some time in the future?
I think it may turn out to be an anti-pattern, yeah. That may be the case. And will it die off? not quickly. There's so much stuff that's written in Java that's now considered legacy, and it's going to be there forever, and we're stuck with that. So I don't see it going away. What I'm hoping is that we'll see new languages that become liberated from that idea and can take full value of objects without the tight coupling, maybe with functions or maybe with actors or some other technique, and we'll go forward from there. But once something gets into the enterprise, it stays there for a long, 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 long time.
Okay, thank you very much.
Hi, thank you for the speech. I have a question about languages and what they can teach us. You have examples, bad languages with bad things, what language can teach us.
What does a language teach you?
Помочь можете? Плохие вещи, которые может научить. Какие-нибудь примеры языков программирования, которые плохого могут научить.
I'm just trying to translate, sorry. What are the bad examples of the programming languages you can say? Just.
What can teach bad things, bad practice, like PHP, JavaScript, or not?
Right, so PHP is not a language I would recommend. Visual Basic is not a language I would recommend. But Scala, I would highly recommend that. You should look at that. I don't recommend Java anymore, but Clojure is good, so there's some good things in the JVM. F#, which runs in the Microsoft world, is an interesting language. Haskell, which is a pure functional programming language. I'm not an advocate of pure functional programming just because they don't allow for any kind of mutation. They don't allow anything to change. But programs need to interact with the world, and the world changes. And so that becomes a difficult thing. But even so, I think there are things that we can learn from pure functional programming. And the more purity we can put into our functional programs, the better off we are. Did I answer your question?
Yeah, thanks.
Oh, thank you.
Thank you for your talk. Yesterday we heard many approaches to add new types in JavaScript. What do you think? What best approach to add types in JavaScript?
I think the best approach is to not try to put types into JavaScript. So when I started with JavaScript, I'd been doing a lot of Java, and so I was very comfortable with the idea of strong typing. And I was very nervous about writing in JavaScript without strong typing. And I was very concerned, is it possible to make good programs? And I discovered some things. One was that even though you have strong typing in Java, you still have to test, right? So even though there's typing, it's not nearly good enough to find all of your bugs. You still have to test anyway. So it actually isn't doing as much good for you as you think it does. And that it's actually causing some bugs. The fact that you can't get special values out of something that's an int, or that a method can only return one type of thing, even though there might be multiple types of things that might happen, and so you get overloading of exceptions and using exceptions as covert channels for getting stuff around the type system, which causes other errors. You get all this compounding of things. Whereas in JavaScript, none of that happens. In JavaScript, everything is generic, everything works. The defaults are right, that if you try to call a method on something which isn't an object, or it's an object that doesn't have that method, it throws an exception, which is exactly the right thing for it to do. And so it turns out that you can write very reliable programs in JavaScript unless you write in a style which is trying to pretend to be another language. The worst JavaScript I see being written now is JavaScript in a Java style. And when you write in that style, you got the coupling and all of those problems, but without a type system to help you manage it, and it gets really, really difficult, and you get architectural problems. But I think if you're writing JavaScript in a functional style, those problems do not occur.
Okay, thanks.
Is code review of our pull request in our company on daily basis is like code reading, or did you mean something more when you talk about code reading? Thank you.
Yeah, in my code reading, I want to get everybody together in the same place. We could be all together online, but I prefer to get everybody in the same room, and we're all reading together as a community exercise. So we're doing team building and education as well as code review. So we do all of that at once. So it's not just reading the pull requests, it's reading everything together. And also, as part of that, we can also talk about strategy, about what we're going to do today and tomorrow and who's going to do what and so on, that we can make adjustments to the project as a result of what we read today. What's my opinion about pair programming?
Yeah.
I've seen it work really, really well. So it's an interesting practice. I don't know why it isn't used more often. I guess there's a perception that it makes everything twice as expensive, except the quality that you get from it, I think, more than pays for that loss of productivity. So I think pair programming is an excellent practice.
Douglas, can you please say what are the good parts of E programming language and what can be its future?
What are the good parts of the E language?
Yes. Yes.
Really, you're asking me about E? Nobody's ever asked me about E. Okay. So there are actually two E languages. So years ago, I started a company called Electric Communities, and we built our own programming language called E, and the first version of E was modifications to Java. So we added to Java communications channels and messaging through those channels. And it was great. It was intended for doing distributed systems, so that I could create a channel and I could send one end of the channel to another machine, and once it receives it, we can then communicate through that channel. And it was a really nice programming model. And then we did a second version of E, which moved away from Java and was its own language, and it was a very, very nice language. I liked E a lot. So trying to remember what the bad parts of E were. Well, of the first E, the bad parts were Java. There's a lot of Java in it. The second E didn't have quite so much Java in it, and so I think it was a nicer language. Oh, and then the interesting thing about the second E is that is where actors came from. The first time we saw actors was in E, and then that idea for actors got copied into Python and then into JavaScript.
Hello, Douglas. Recently you said that PHP is a bad thing. Can you tell more about this? Why it is bad?
Why what?
Why PHP is a bad thing? For beginners also.
Oh yeah, especially for beginners. Yeah. So the guy who designed PHP is a really nice guy, really smart guy, but he was not a language designer. He was just trying to hack something together to make websites, and it kind of accidentally evolved into a programming language. But he's the first guy to admit that he didn't know how to design a programming language. And so there's a lot of weirdness in PHP, so I just wouldn't start there.
Thank you very much for your talk. You said that bad JavaScript gets written when people try to write it as if it were another language, right? But what if I have like my coworkers that come from different backgrounds, from different languages, and they try to do that thing? How do I like prove to them that this is an inferior paradigm or something? How do I convince them?
Well, you could give them a book. Yeah, somehow you have to, and the code reading thing might help in doing that they can see what you're writing, and ultimately they might figure out that the way you're writing is more effective than the way they're writing, and eventually they might get it.
Well, I'll try that. Thank you.
I have one more question about languages. Is JavaScript is a good choice for the first language? And second question, what language you recommend for the first time to learn to be a good programmer?
So you ask me, do I think JavaScript's a good language?
No. I ask about what the first language must learn the man who want to be a good programmer. What you recommend for the first choice?
What should be a first language?
Yes.
That's a really good question.
And is JavaScript is a good for the first language?
It could. So I once taught a high school class JavaScript. So it was a beginning programming class. I taught the class because I thought I might want to write a book about beginning programming. And so I got the use of a high school class and taught them JavaScript. I ended up not writing that book, but it was a really nice class, and the students did very well in it with JavaScript. The problem with JavaScript is it has so much weirdness in it that it's really easy to trip over things and accidentally get into a state where you don't understand what's going on. And so you can mitigate that a little bit by using JSLint, but putting those sorts of tools in front of someone who's just trying to learn and get started could actually make things harder. So that's a difficulty.
Okay, thanks.
Another question. I imagine, as most of us here, we know JavaScript, and to some extent probably C++, because it's taught in universities, and probably to some extent again PHP. So if I were to decide to learn one single programming language, what would you recommend to be my first pick?
It depends on, do you want to learn it so you can get work, or do you want to learn it to get smarter?
I want to learn to get smarter.
Then I would consider looking at Erlang right now. I think Erlang has more new ideas expressed in an interesting way than any others. And if you don't like Erlang, there are now dialects of Erlang, that are being compiled into the Erlang VM. So I would start there.
I see. Thank you.